Hey everyone, and welcome back to the channel. Have you ever looked up at a spectacular firework display and wondered, how do they do that? How do they get those incredible colors, that booming sound, and those amazing shapes? Well, you've come to the right place. Today, we're diving deep into the dazzling world of pyrotechnics to uncover the amazing chemistry that makes fireworks possible. It's a story of fire, physics, and some fascinating chemical reactions. So, grab your safety goggles, figuratively, of course, and let's get started. First things first, what exactly is a firework? At its core, a firework is a carefully crafted package of chemical ingredients designed to burn in a specific way to produce light, sound, and color. The most common type you see is the aerial shell. Think of it like a little rocket. Inside the shell, you have several key components. There's a lifting charge, usually made of black powder, at the bottom. This is what propels the shell high into the sky. Then, inside the main casing, you have the bursting charge, also black powder, and the most important part for the visual effect, tiny little pellets called stars. These stars are the real magic makers, and what's inside them is where the chemistry truly shines. So, let's talk about those stars. Each star is a small, compact ball of fuel, an oxidizer, a colorant, and a binder. The fuel is what burns, providing the energy for the reaction. Common fuels include things like charcoal or sulfur. But a fire won't burn without oxygen, right? That's where the oxidizer comes in. Oxidizers are chemicals like nitrates, chlorates, or perchlorates. They are packed with oxygen atoms and release them when heated, allowing the fuel to burn very rapidly and intensely, even high up in the atmosphere where there's less oxygen available. The binder, often a substance called dextrin, is like a glue that holds all these ingredients together in that neat little star shape. Now for the part you've all been waiting for. The colors. The brilliant colors of fireworks are created by adding different metal salts to the star mixture. It's the same principle that you might have seen in a high school chemistry class. When these metal salts are heated to extremely high temperatures, their electrons get excited and jump to higher energy levels. But they can't stay there forever. As they fall back down to their normal state, they release that extra energy in the form of light. The specific color of the light depends on the type of metal used. It's like each metal has its own unique color signature. Let's break down the color palette. For a brilliant red, pyrotechnicians use strontium salts. If you want a vibrant green, you'll need barium compounds. For a beautiful blue, copper salts are the key. Blue is actually one of the trickiest colors to create because the copper compounds are temperature sensitive. If the reaction is too hot, the color washes out. To get that deep, rich blue, the chemical formulation and burn temperature have to be just right. For a bright yellow or gold, they use sodium, the same element that makes table salt, and you can even mix these. For instance, mixing strontium for red and copper for blue can create a lovely purple. It's literally painting the night sky with chemistry. But what about those dazzling glitter or sparkle effects? Those long, shimmering tails are created by adding metals like aluminum, iron, or magnesium to the mix. Instead of burning up instantly, these metal particles heat up until they are incandescent, basically, glowing hot and leave a trail of sparks as they fly through the air. The size of the metal flakes determines the effect. Fine powders create a short, shimmering burst, while larger flakes will produce longer-lasting, brighter sparks. Some effects, like the strobe effect, are created with specific mixtures, often containing magnesium, that burn in a series of rapid flashing bursts. It's all about controlling the rate and style of the burn. And we can't forget the boom. The loud report you hear from a firework is a result of the rapid combustion of the bursting charge, which is typically more black powder. When the firework reaches its peak altitude, a time delay fuse ignites this charge. The black powder burns so quickly inside the confined space of the shell that it creates a massive instantaneous buildup of hot gas. This gas expands explosively, tearing the shell apart and sending the stars flying outwards. The resulting shock wave from this rapid expansion travels through the air to our ears as a loud bang. The bigger the shell and the more bursting charge, the louder the boom. Let's quickly talk about the different shapes. How do they make hearts, smiley faces, or stars in the sky? It's actually a wonderfully clever bit of arrangement. Inside the aerial shell, the stars aren't just thrown in randomly. They are carefully placed and glued onto a piece of cardboard or paper in the exact pattern of the desired shape. When the bursting charge in the center of the shell ignites, it explodes outwards with equal force in all directions. This pushes the stars outwards, preserving their original arrangement. So, a circle of stars becomes an expanding circle in the sky. A heart-shaped pattern becomes a heart in the sky. It's a perfect example of symmetry in physics working hand in hand with chemistry. Of course, with all this fire and explosive chemistry, safety is the #1 priority. Professional pyrotechnicians are highly trained experts who understand the immense power they are working with. From manufacturing to transport to the final display, every step is strictly regulated. They use remote electronic firing systems to launch the fireworks from a safe distance and meticulously plan their shows, taking into account wind direction, weather conditions, and the safety of the audience. So, while it's fun to understand the science, it's crucial to remember that fireworks are not toys and should always be left to the professionals. So, the next time you're watching a fireworks show, look beyond the pretty lights. See the strontium burning to create that crimson red. Hear the rapid expansion of gases in the thunderous boom. I appreciate the barium salts painting a stroke of green across the canvas of the night. You're not just watching a celebration, you're witnessing a breathtaking display of applied chemistry, a perfectly choreographed ballet of elements, energy, and light. It's science at its most spectacular. Thank you so much for joining me on this explosive journey into the chemistry of fireworks. I hope you found it as fascinating as I do. If you enjoyed this video and learned something new, please give it a big thumbs up. And don't forget to hit that subscribe button and ring the notification bell so you don't miss our next deep dive. Got any questions or ideas for future topics? Let me know in the comments below. Thanks for watching, stay curious, and I'll see you in the next video. Hello everyone, and welcome back to the channel. Tonight, we're lighting up the sky with a topic that's truly explosive, the chemistry of fireworks. Have you ever looked up at a dazzling display and wondered, how do they do that? Well, you're about to find out. We're going to dive into the science behind those brilliant bursts of color and sound. It's a fascinating mix of physics, chemistry, and pure artistry. Before we get into the nitty-gritty, let's talk about the unsung heroes of fireworks history. Believe it or not, animals played a role. Ancient Chinese legends tell of a mythical beast called the nyan, which was said to fear loud noises and the color red. To scare it away, people would burn bamboo stalks. When the air trapped inside the bamboo heated up, it would expand and burst with a loud bang. This simple act was one of the earliest forms of firecrackers. So, in a way, we have a mythical monster to thank for kicking off this whole spectacular tradition. From those crackling bamboo stalks, the technology evolved. The real game changer was the discovery of gunpowder around the 9th century in China. This mixture, a powerful combination of potassium nitrate, charcoal, and sulfur, is the foundation of modern fireworks. It serves two main purposes. First, it's the propellant that launches the firework shell high into the sky. Second, it's the bursting charge that makes it explode into a beautiful pattern once it reaches its peak. Let's break down the gunpowder recipe. Potassium nitrate is the oxidizer. Think of it as the air for the fire. It provides the oxygen needed for the fuel to burn very, very rapidly, even when packed tightly inside a shell. The fuel components are charcoal and sulfur. Charcoal, which is mostly carbon, provides the primary fuel source. Sulfur helps to lower the ignition temperature, making it easier for the gunpowder to light, and it also increases the speed of the reaction. When these three are mixed in the right proportions, you get a powerful fast-burning substance that can launch a projectile hundreds of feet into the air. Now for the really magical part, the colors. How do fireworks paint the night sky with vibrant reds, blues, and greens? The secret lies in chemistry, specifically in metallic salts. When these salts are heated to extreme temperatures by the explosion, their electrons get